We celebrated the wrong milestone. When Voyager 1 crossed into interstellar space, the headlines called it humanity's first step beyond the solar system. A machine had finally left home. It felt like a frontier, the edge of everything we know, the door out. But that edge is an illusion. The solar system isn't a continent we escaped. It's a single grain of sand on a beach that stretches 100,000 light-years across. Leaving it is not the beginning of the journey out. It's the first inch of it. So here's the real question, the one almost nobody asks. Forget the solar system. How long would it take to leave the entire galaxy, to break free of the Milky Way completely and turn around to see all of it from the outside? The answer isn't a big number. It's stranger than that. Because for anything humanity has ever built, or is even close to building, the honest answer is a single word: never. Let me show you why. Start by throwing out the picture in your head. Most of us imagine the Milky Way the way it looks in a photograph. A glowing pinwheel seen from above, neat and finite, something you could point a ship at and simply fly out of. But you have never seen the galaxy from the outside. No one has. No camera ever built has captured the whole Milky Way, and none ever will. Every image of the complete galaxy is a reconstruction, an artist's best guess, stitched together from measurements taken deep inside the thing itself. And from the inside, it is monstrous. The galactic disk spans roughly 100,000 light-years, edge to edge. Light, the fastest thing that exists, moving at 300,000 kilometers every second, needs 100,000 years just to cross it a single time. The disk we live in is about 1,000 light-years thick, a luminous sheet holding somewhere between 100 and 400 billion stars, and we are nowhere near the middle of it. Our sun sits about 27,000 light-years from the galactic center, tucked into a minor spiral arm stranded roughly halfway between the blazing core and the faint outer rim. Let that distance actually land. If you shrank the whole Milky Way down to the size of a country, the gap between us and the nearest star beyond the sun would be thinner than a human hair. And Voyager, after more than 45 years of flight, still hasn't crossed even that hair. So we are not standing on a map, scanning for the exit. We are buried inside a structure so vast that the word distance begins to break down. And before we can ask how fast to run, we have to answer something far more basic. Which way is out? Because the answer is not the direction you would expect. There are two ways out of the Milky Way, and one of them is a trap wearing the mask of the obvious choice. The obvious choice is to run for the rim, fly sideways along the flat plane of the disk, straight out past the spiral arms toward the edge. It feels correct. It's the direction the galaxy is widest, the way that looks like a way in every picture we've ever seen. But from where we sit, 27,000 light-years out from the center, reaching the far edge of the disk means crossing more than 25,000 light-years of the most crowded real estate in the galaxy. Gas clouds, nurseries of newborn stars, the combined gravity of billions of suns clawing at you the entire way. There's a shorter path, and it points in a direction almost no one thinks about, straight up. Remember, the disk is only about 1,000 light-years thick, and we sit close to its middle, so instead of crawling sideways across tens of thousands of light-years, you could punch out perpendicular to the disk, up through the top, or down through the bottom, and break the plane of the galaxy in just 500 light-years. That is the express lane, 50 times shorter than the run for the rim. For one glorious moment, it feels like you've beaten the problem. You've found the cheat code, aim up, and the galaxy is thin enough to slip out of. But this is exactly where the trap springs shut. Because breaking out of the visible disk, leaving behind the stars, or the spiral arms, The glowing river of light we actually call the Milky Way does not mean you've left the galaxy, not remotely. The part of the galaxy you can see is the smallest part of what is holding you in place. The real Milky Way is far larger than the one that shines, and it has no intention of letting you go. Above the bright disk, the sky goes black, and that is when the cage reveals itself. Punch out of the glowing galaxy, and you'd expect open, empty space. Instead, you'd find you are still inside the Milky Way, just inside the parts of it that give off almost no light. Wrapped around the disk is a vast, faint sphere called the halo. Scattered through it are the galaxy's oldest stars and around 150 globular clusters, tight knots of hundreds of thousands of suns, some of them orbiting tens of thousands of light years above the plane you had mistaken for the edge. But the stars in the halo aren't the real problem. The real problem is the thing you can't see at all. The Milky Way is buried inside an enormous shell of dark matter, invisible, intangible, betrayed only by its gravity, and the amount of it is staggering. Dark matter outweighs every star, every planet, every atom of ordinary matter in the galaxy by roughly 5 to 1. This shell doesn't end where the disk ends. It stretches outward for hundreds of thousands of light years, a gravitational cage that makes the glowing spiral trapped at its center look small. And that cage has a grip you can put a number on. It's called escape velocity, the speed you need to break free of the galaxy's gravity forever and never fall back. Out here near our sun, that speed is about 550 kilometers per second, 550 kilometers every single second, not per hour, per second. Burn that number into your mind because everything from here depends on it. To leave the Milky Way, you don't merely have to travel far. You have to move faster than 550 kilometers per second, fast enough to rip yourself free of a mass you cannot see, cannot touch, and cannot steer around. So, the whole question collapses down to one honest test. How fast can we actually go? Here is where the dream quietly dies. Voyager 1 is the most distant object humanity has ever launched, a probe that has been flying for over 45 years. Its speed relative to the Sun is about 17 kilometers per second. That is blisteringly fast by any human measure. And set against the galaxy's escape velocity of 550 kilometers per second, it is almost nothing. Voyager is moving at barely 3% of the speed it would need to get out, but Voyager is decades-old technology. Surely our newest machine does better. It does. The Parker Solar Probe, flung around the Sun on the tightest, most violent orbit we've ever flown, has reached about 192 kilometers per second, the fastest any human-made object has ever moved. It is a genuine triumph of engineering, and it is still nearly 3 times too slow to escape the galaxy. Our absolute record holder at its absolute peak would slow, stop, and fall back in. Sit with what that actually means. It isn't that leaving the Milky Way would take a very long time. It's that at the speeds we can truly reach, you would never leave at all. You wouldn't drift slowly towards some distant exit. You would settle into orbit, circling the galactic center forever, exactly the way our own sun does right now. The sun sweeps around the core at about 230 kilometers per second and still needs 230 million years to finish a single lap. In its entire existence, it has completed roughly 20 orbits. That's it. And even if we somehow cracked physics, even if we reached 550 kilometers per second and aimed straight up through the thinnest part of the halo, the sheer distance would still devour tens of millions of years before we finally cleared the galaxy's gravitational reach. Now hold that against us. All of recorded human history, every empire, every war, every word ever written down, fits inside about 5,000 years. The journey out of our own galaxy would take that entire span of civilization, repeated thousands of times over in one unbroken straight line without ever slowing down. We are not slow. We are caged. So let's answer the question honestly, one last time. How long would it take to leave the Milky Way? For us, for humans, for our machines, for anything we have built or can seriously imagine building, the answer is not a number of years. The answer is that we cannot. And not because we're short on brilliant engineers, because the cosmos was constructed at a scale that makes the entire attempt almost meaningless. The galaxy was never a place we were visiting. It's a prison 100,000 light years wide, and we were born deep in the heart of it. And yet, there is one way out. Exactly one. And the strangest part is that we don't have to lift a finger to take it. In about 4.5 billion years, the Milky Way will not be alone. The Andromeda Galaxy, right now, nothing but a faint smudge in a dark sky, is falling toward us at roughly 110 kilometers per second. It will arrive. The two galaxies will slam into each other and tear straight through, and over hundreds of millions of years, they will merge into something entirely new, a single, vast elliptical galaxy that astronomers have already nicknamed Milkomeda. In that collision, stars will almost never strike one another. The distances between them are simply too enormous. But their orbits will be thrown into chaos. Entire neighborhoods of stars will be slick-shotted outward, hurled into the black on wild new trajectories that finally, after all of this, carry them free of the wreckage. That may be the only way anything ever truly leaves the Milky Way. Not by escaping it, by being thrown clear when it dies. We spend our whole lives dreaming of reaching the stars, as if the galaxy were a doorway waiting to be opened. It isn't a doorway, it's the room. And the strangest truth of all is this: we will never walk out of it on our own. We can only wait quietly for the day the galaxy itself carries us somewhere new, whether we are ready to go or not. We measure our entire history in a few thousand years, and the galaxy won't even let us leave the room. Subscribe and keep looking up.